How's it going, guys? I've got a good one today, and I think this is going to be a lot of fun, probably the best video so far. And what we're going to do is this car over here has a blown head gasket, kind of a minor blown head gasket. And what we're going to do is scientifically examine all kinds of ways, from established ways that use equipment that most home mechanics would not have, all the way up to just some kind of crazy ideas that maybe I'll just make up. And we're going to see which of these methods work the best for diagnosing a head gasket failure. And to do that, we are going to do it scientifically, which means we're going to need a control, a negative control. And what that means is we need a car that does not have a head gasket failure. The reason is because a good head gasket test is not only going to be able to detect when you have a blown head gasket, but it also will not give a false positive on a car that doesn't have a head gasket problem. The only thing worse than diagnosing that you've got a head gasket problem is misdiagnosing and calling one when you don't have one, right? So that's what we're going to do today. So let's go find a control vehicle. Okay, that ought to suffice, because if this car has a blown head gasket on it, then I'm going to be very angry, because this is my car and it's my baby. So first of all, first things first. Before we get started, 3 very important things if you're not really intimately familiar with some of the common tests that we're going to do, or with a head gasket failure in general. Number 1, when I say a blown head gasket, this is a generic term that is often thrown around for any time that you have some type of compromise with the engine where there is a crack or pathway or blown gasket or some kind of connection between a combustion chamber and the cooling system. This may not necessarily be from a blown head gasket, literally. You could have a crack in the engine block where the crack is located between the combustion chamber and a coolant passage. You could have a cracked cylinder head. You could have a warped cylinder head. Which of course would most likely cause another condition, which would be a actual blown head gasket, a failure with the head gasket. But just keep in mind that there could be other things that would cause the conditions that we're going to test for besides a literal blown head gasket, and you cannot tell the difference between them. The symptoms with a cracked block versus a cracked cylinder head versus a literal blown head gasket are identical. So when I say blown head gasket, I'm referring to any of those conditions. The second condition, there are other serious engine problems that we will inadvertently detect with some of these tests that may not necessarily mean the combustion gases are connected in the coolant. You could have, for example, a loss of cylinder compression, but the compression does not have to be going to the coolant. It could go to the adjacent cylinder if there is a crack between the cylinders. It could go to the oil system. It could go to the outside of the car. So just because you pass all of your head gasket tests, that doesn't necessarily mean you're out of the woods. And the final thing to know is, if you do find that you have a literal blown head gasket, you do not fix it by replacing the head gasket. Something caused the head gasket to blow. Most likely you're going to find that there's either some type of warp with the cylinder head, where that warp is still there if you replace the head gasket, a crack in the cylinder head, maybe a crack in the block. So don't just replace a head gasket if you find a diagnosis that shows this. The best thing to do, take the cylinder head to a machine shop, have them measure it up, and check for cracks, magnaflux they call it. But don't just replace a head gasket. So that said, let's do this. What we're going to do is do the tests kind of in order from my favorite, most definitive tests, and then we'll start getting to some more kind of shade tree mechanic tests. So the first thing we're going to do is we have to definitively prove that there is a blown head gasket here. And again, by that I mean combustion and the coolant channels are somehow connected. What's a great way to do that? Well, my favorite is, because I'm a scientist, with a chemistry test. And what this is a combustion chemistry test. if you think about it, since the cooling system should be completely separate from any combustion, there should be no combustion gases in your cooling system for any reason. And what this does is it tests for carbon dioxide. As you know, carbon dioxide and water and carbon monoxide are all outputs from the exhaust. If carbon dioxide, which is what this tests for, is present in your cooling system, you have a definite 100% connection between the combustion and the cooling. Maybe blown head gasket, cracked block, whatever. But that's what we're going to do to definitively prove that we do have a blown head gasket in this engine. All right, so what I'm going to do is take off the radiator cap, make sure there's a little gap with the coolant and the neck, and take my tester. And what we're doing is we're looking for the fluid in the tester to turn yellow. If it turns yellow, there is carbon dioxide in here. We can see it's already turning yellow. All right, that is definitely much more yellow than it was before. And you notice, by the way, the car with a little bit of an exhaust leak, but it actually runs really well. It actually takes a long time before it overheats. The car really does seem to run pretty well despite having the blown head gasket. So you can have different degrees of leakage, but one of the things is, will that test just turn yellow with any car? So what I'm going to do is, on my Trans Am, we're going to remove this radiator cap here, being a little stubborn, and we're going to repeat the test on this car. And the test better not turn yellow. But we're going to go ahead just to show that that test actually works. All right, let's go ahead and do it on this car. And already you can see the bulb is having trouble inflating. Let's put that in the camera. See how the bulb here is still having a long time before the bulb inflates, which is a really good sign. It means that unlike the other car, there is no gas coming in to the cooling system. I have to let up on it a little bit to draw gas. It means the cooling system is sealed, which it should be. There is no gas entering the system to fill the bulb. So right off the bat, that's a good indication here. But let's just keep doing this for a couple seconds, and we can see there is no color change at all, which makes me happy for two reasons. First of all, because my car doesn't have a blown head gasket. And second of all, it means we have a good control for the rest of our testing. And that's negative. That's not turning yellow at all. All right, I actually really like that test. It's kind of scientific-like, and also the other cool thing about that test is it's very portable, doesn't use any special tools. I very often bring that exact kit with me whenever I'm doing used car inspections, and I'll just pop that on there just to see if I can test for a head gasket problem. Now, keep in mind that just because you are negative with that chemistry test, it doesn't mean that you're out of the woodworks if you think you have some kind of compression problem. If you have a problem where you have worn piston rings and the compression is going into the oil pan, or you have a leak between combustion chambers, adjacent cylinders have a crack, so the combustion is going from one chamber to the other and vice versa, those won't be detected by this test. If you have a valve problem, the valves aren't seating right, or a cracked valve or something where the combustion would go through the intake valve or through the exhaust valve, none of those will test positive with the coolant test because the coolant isn't involved in any of those, and yet you still have a serious engine condition, which at minimum would require removal of the cylinder head. So just, again, keep that in mind and understand what these tests do. So the second favorite test that I'll do is, of course, the compression test. And what we're going to do is a compression test on this engine. I won't do one on the positive control because we know that we're going to see, I already know where the problem is. And the other cylinders act as a control. We're going to see one cylinder which has really low compression compared to the others. That is going to be a positive compression test. It kind of already has its own control built in. So let me go ahead and get some spark plugs out of here and we'll do the compression test. All right, and while I do this, I'm going to give a little plug here. The next video that I do, we're going to do a scientific test of some of that liquid block sealer or head gasket repair, the liquid head gasket repair stuff that you sometimes seen. So this car is a perfect candidate for that. And what we're going to do is do a scientific test of that stuff by taking before and after measurements on the engine and seeing if that stuff really actually does return normal compression. We'll also do that chemistry test. So keep an eye out for that video coming up pretty soon. All right, and incidentally, for you guys that like to test spark plugs or look at spark plugs or read spark plugs, whatever you want to call it, I do not do that. I wouldn't know what I'm looking for, and I personally don't believe in it. But here are the spark plugs from the engine, and you tell me which of these is from the cylinder with the blown head gasket. All right, it is this one. Right here, out of all four of them, it is this guy. So whatever there is about that one that looks different from the others, I would like you to tell me. All right, we're going to test on number one, and to make things easier, I've got a little remote starter thing here that I set up. So let's see. All right, and we've got about 150 on number one, so that's actually pretty good. Let's move the gauge to number two. All right, here's our gauge at number two. Oops, lost our gauge there. And it's a little bit lower. It's at 130, which is probably still within spec, but let's go on to number three. All right, and I'm expecting to find a significant drop here. One of the things I want you to notice about this compression test is it's not going to be able to tell you where that compression is lost to. It could be past the rings, there could be a cracked valve, there could be any other combination of things besides a blown head gasket. We don't know why there is a loss of compression if we find it. We just know that there is one, but it doesn't say where. The next test we do, the leak down, will actually tell you where. All right, let's do this one. Oops, lost our gauge there. Let's make sure it's in the shot. All right, here we go. And we can see that one has a lot of trouble getting past 120. Now notice that the other cylinder was pretty low too, the one adjacent, but that one read actually a little over 130. Had those been identical readings on those two cylinders, I would have strongly suspected the compression is going between the two cylinders through a crack, which may or may, again, not be a head gasket. But let's go ahead on to number four and see what we get there. All right, and here is at number four. We see we get up to almost 150, about 145 or so. Okay, so I did actually take the time to go ahead and look up the specs, and this engine's in a little trouble. The highest compression reading I got was about 150. The minimum tolerable compression from any cylinder is supposed to be 142, and the specification is no more than 14 psi difference, which we got well over that difference between a couple of the cylinders actually. So that is confirmation that we have loss of compression, not necessarily confirmation of loss of head gasket integrity, but combined with the chemistry test that we did, it's a pretty safe assumption that we do have combustion going into the cooling system. And again, whether it's head gasket, cracking the cylinder head, cracking the block, whatever. But the next test that we're going to do is the leak down test, and the leak down test is similar to a compression test in that we're going to look at compression in the cylinder, but we're going to be able to see where the leakage goes, and my bet is we're going to see it in the cooling system. So let's go ahead and do that. All right, set up cylinder leak down test. This is actually my favorite test because it does the same thing as the compression test but gives more information. Do know, by the way, that with these three main tests that are the only three that I really totally think are self-standing as far as diagnosing a severe engine problem, if you have a positive on any of these tests, at the very best, that cylinder head's coming off. So just keep that in mind. That's one of the reasons why I do these tests first. So let me go ahead and set this up. So because cylinders number 2 and 3 were the low ones, what we're going to do for comparison is cylinder number 1. But remember, this cylinder is barely in spec. So what we're going to do is, I do my leak down a little different here. But what I'm going to do is set up this hose and then close the cylinder. What we're doing is feeding compressed air at 90 psi directly into the cylinder, creating compression, and we're going to see how much leak down there is. So let me get on the gauge here. Okay, so as we see right now, we're at a very high leak down reading, and that's okay. That's because right now it's actually going through the intake valve. It sounds like, you can maybe hear that whistle a little bit. It sounds like it's going through the intake, but that's okay because when I rotate the engine over here, that intake valve is going to close, and there it is right there. The compressor just went on. Hang on. All right. That was more annoying than listening to a liberal. All right, let's go ahead and shut that intake valve. And as you'll see, it's now dropping to low, and it's about, what is that, maybe 30%. I can't really see through the camera. That's not fantastic, but that is acceptable. So that cylinder would pass the leak down test. So let's go ahead over to number 2 and see what happens. All right, so here we are at number 2, and let me crank past. We're on the exhaust. Now we're on the intake there. Yeah. And let's see what we get here. So now we're at moderate, which right here, if you found this, you've got a problem. But here's what's interesting. You can hear bubbling. Let's see if I can put this by the radiator, this microphone. See if you can hear that. And that is going to be because it is connected into a coolant passage, blown head gasket or crack or whatever. Hopefully you can hear that. That is definitely confirmation on why we saw that coolant test, the chemical test, positive, because there is definitely a connection somewhere between the combustion chamber and the coolant channel. All right, so another test we can do is we can actually take off this radiator cap, and we can see if the bubbles from the compressed air entering the cooling system bubble up through the radiator. And well, let's see, right now the radiator is a little bit low, which is to be expected because of very typical of blown head gasket. But let me go ahead and get some coolant added in there, and we'll see what we can find. And what we're looking for is any bubbles when I compress this. Oh, well, there you go. That's all I need to see. Okay. I think we're done there. All right, you cannot tell me that that wasn't cool. Hopefully you're having a good time with this video as much as I am. And I'm going to just go ahead and do that leak down on number 3 as well, since cylinder number 3 had the lowest compression. And there's really no need to do this. Once you get a bad compression or a bad leak down test, you're done. It really doesn't matter whether you have one cylinder or multiple cylinders because the repair is going to be the same. But I'm just curious here. All right, and now I'm at, let's see where we're at here. Well, we've got quite a bit, as expected, quite a bit more leak down in this cylinder, and I can really hear the coolant bubbling quite a bit. So I'm not even going to take that cap off because I don't want to make a mess all over the floor. So we have a breach both at cylinder number 2 and 3 to a coolant passage. All right, and this is just for scientific purposes here, but I want to remeasure number 1 and verify. Actually, let me take this cap off because I know that nothing's going to spill out. And this is just to show that this test will not give a false positive result. So let's roll this over, get to the compression. There we go. All right, so that should be reading good. And we see nothing's boiling out of the radiator cap, and I don't hear any bubbling of the fluids. So just goes to show that this leak down test is very accurate and very reliable and reproducible. So we can't get a false positive out of it. What we've done there is pretty much the established tests. There is no question about it. We have 100% confirmation. We have a blown head gasket, however you want to call it, with this engine. So what we're going to do now is start looking at some of the more shade tree tests and compare those, of course, on the control car and see if, without any of this equipment or anything, if you can still accurately diagnose a head gasket all the same. So let's go ahead and try that. All right, and one last thing, I apologize. There is one other kind of standard test, although it's not a standalone test like the other ones that would indicate that you've got a serious engine problem. That is the cooling system pressure test, which unfortunately I am not going to be able to do on this vehicle because the radiator cap here is all chewed up, and that's actually strongly why I suspect that the engine overheated, was because the radiator cap doesn't even fit on here, much less my cooling pressure adapter. But what this is, it's just very simple. This is just a little pump that hooks up onto the cooling system. You pump pressure into the system, and this will force the coolant under pressure through any leaks, including generally a head gasket leak. The thing with that pressure tester is a couple-fold. First of all, it doesn't put nearly the pressure into the system as the leak down or compression test does. Really, you can only put a maximum of maybe 20 psi or something like that. It may not be enough to force coolant through a head gasket crack or a block crack. And the second thing is, remember, this is not a definitive test for a head gasket like the other ones can be. With this one, any leak, a leaking hose, a leaking clamp at a hose, something like that, leak at the water pump, anywhere where there's a cooling system leak, that will show up as coolant leaking out of the system. The other thing to remember is you can also have an intake manifold coolant leak. This was actually very common on some of the earlier 2000 model GM cars with the 3.4 and 3.1 liter engines. That would be coolant getting into the oil, which of course is something we're going to check soon, but without it being from the compression chamber. It's entirely possible that with this test, if you have an intake manifold coolant leak, that you would find that. That would be a leak that is negative on a compression test and a leak down, and of course on your chemistry test, but still a very serious condition because you're getting coolant into the oil system. So unfortunately won't be able to show that test today, but what we are going to do now is go ahead and do a typical shade tree test. We're going to go ahead and look at the oil. And as is normal with a lot of times when people have engine problems, what's the first thing they do? They try to change the oil. So I don't expect that to be different here. And we can look at the oil dipstick here and we can see the oil's not all that new, but it is not milky and foamy and all that like we would pretty much expect. So maybe this oil just isn't old enough to show that problem yet, but we don't see anything abnormal on the oil there. The other typical test for your shade tree mechanic is to look at the oil fill cap and see if that looks milky. And there we go. So let's go ahead and take a look at that. And we can look at the cap here and we can see that it looks just fine. So there's no milky residue on it. So both of those tests are not very reliable for detecting a head gasket because we know for a fact we have a problem on this car with the head gasket leak. So let's do this. Let's go ahead and drain some oil out from the oil pan. The theory is that the coolant and oil mix, the oil looks good because the engine just hasn't run long enough. But actually what's happening is there's a whole bunch of coolant in the oil pan, and if you drain the oil, a bunch of coolant will come out first because of course oil floats on water. So let me go ahead and do that and get a sample of the oil from the oil pan and see what that looks like. Here is our oil, and let me go ahead and get some light on there so you can see, but I can tell you right now it looks totally normal. All right, so we can look at the oil and there you go. And you can see it does not have a milky, milkshake-like appearance. I have other videos that show very clearly what a blown head gasket oil mixture looks like, but that just looks like it needs an oil change. And that's a little disconcerting because I've mentioned before several times how I like dirty oil in the cars because it increases the chance of you finding a problem. But in this case, that's not so. This just looks like it would need a regular oil change. If I were changing the oil in this car, I wouldn't even notice any problem. All right, as long as I've got everything kind of taken apart in this car and I've got to put it back together before I can run it again, we're going to do a couple other tests that are kind of shade tree-like. And one of them is we're going to look and see if coolant billows out of the spark plug hole while we're cranking the engine. And I've actually seen this happen before and it's pretty cool. So what I'm going to do is this. All right, I'm going to take a white piece of paper and put it over the two spark plug holes that I suspect have the problem, and we're going to go ahead and crank over the engine, and then we'll see if any coolant, it'll be easy to see on the white paper, and we'll see if any coolant gets onto the paper, again indicating that you've got coolant in the combustion chamber and you've got a problem. So let me go ahead and set up my starter. All right, let's see what happens. All right, we've got a little bit of liquid on the paper, but again, that could be fuel. So that's kind of interesting. I'm not sure what to make of this, but you can see a little pattern here just only over the number 3. And it does not smell like gasoline. And number 3 was the one with the lowest compression. That's kind of interesting. Let me try to duplicate that again. For those of you that are molecular biologists, this kind of looks like a dot blot test. All right, let's try it again. How amazing. We definitely have on number 3, but it is definitely not gasoline. And if it was gasoline, remember, we'd see that with the other cylinders as well, since they also have gasoline. That's a pretty interesting test. And the thing is, we don't have to do this as a control on the normal car because we have controls built in with the other cylinders that had higher compression tests. So I would say that may be a valid test. Actually, one of the tests that we're going to do is a dye test. And I've got kind of a good idea here. What I'm going to do is I'm going to add dye to the cooling system as part of the dye test. But we'll repeat this test and see if the tracer dye shows up there, which would confirm that that is actually coolant. So this test we're going to revisit. All right, let's do another test.